Alrighty. I want everyone to clap your hands. Congratulations, everyone. You're entering algebra now. We're far away from pre-algebra now. We're in algebra. We are now in equations, people. Hey, no more review. Because it's lecture time. So, we are doing equations today, people. One-step equations. So, for those of you that are just seeing an equation for the first time, it's going to be kind of weird to comprehend, but it's still pretty cool. So, before we were dealing with expressions, right? Like 3x plus 4x plus 6, right? And we had to combine these, right? And we'd get 7x plus 6. All we were doing was simplifying, right? We weren't solving for x. We weren't doing anything. We weren't solving. We were just making a long expression into something smaller. Equations. Equations. Is an expression with variable, but if you notice, it has this little sign. What's this sign called? Equals, equations, equal, equations, equal, do you guys see the similarities? Equations have equal signs. When you see that equal sign, my friends, keep note. You could solve for x. You could solve for x. We're no longer simplifying. That's why I said congratulations, everyone. We're now entering the beast of math, known as equations, in which you are going to be solving for x. Now, use common sense right now. Let's just use logic. 4 plus what number creates 11? 7, right? 4 plus 7 equals 11, right? You could do that with these small numbers. You could easily, logically, using common sense, find what number plus what number, or what number minus a number equals the other number. But the thing is, mathematically, how would you solve this? How would you solve this without just looking and knowing? How would you mathematically write it out to solve for x? Well, there's a process, okay? Are we ready to learn the process? So here's the thing. I want everyone to keep note of this. I want everyone to keep note of this. Treat that equal sign sort of as a divisor of two worlds. We have world 1 and world 2. And world 2, right? Don't like worlds? That's fine. You want to think of neighborhoods? Neighborhood A, neighborhood 2, think of it. Side A, side B, I don't care. As long as you have these two distinct places. And these are the steps with equations. Make sure each side, before you start messing around with moving stuff, make sure each side is as simplified as it could be. This is what I mean. Just looking on this side right here, could you do anything there? No, because 4 and x are not like terms, right? We can't do 4 plus x, right? So guess what? Side 1 is done. It's as simplified as it can get. Now move over to side B. Is there anything you could do there? No, it's just one measly little number. You can't do anything with it, right? But guess what? having that as step number 1 is going to help you with tomorrow's stuff, which is multi-step equations, because you're going to have to do some stuff to simplify, and those stuff is what we've been doing all week, all of last week. But whatever, this is a one-step equation problem. So we did that. There was nothing to do there, nothing to do there. Okay, cool. Now you move on to step number 2. Step number 2 is ask yourself this question. What needs to be moved so that all like terms are on each side? Why are you laughing? What needs to be moved so that all like terms are on each side? What do I mean by that? It's quite simple. We have a number here. We have a variable there. And we have another number there, right? Tell me what needs to be moved. Oh, actually, before I ask that again, pretty much you want to think of it like this. Think of each side, remember the two worlds? Think as world 1 with one type of race, one type of a human being, I don't know what you want to call it, and side B has the other type of race, or Martians, or whatever you call it. We have Earthlings and Martians, right? And you want to ask yourself, if the numbers are the Martians, let's say, and the variable is the Earthling, you want all race in its designated area. That's all you're trying to do, is move each thing to its designated area. This Martian does not want to be over here with the Earthlings. Why? Because we suck. We are nasty people. We're a nasty race. We're a nasty human being race. And it wants to be over there with its buddy, the other Martian, the other number, right? So guess what? I've determined that this 4 wants to move over there. That's what you guys are going to do, is spot the one thing that needs to be moved so that all worlds are happy. Okay? So now comes the third question. How do you move the 4 over there? Yes?
Put a -4 on the bottom and that over there.
Good. So here's the thing. If you ever want to move something over the famous equal sign, if you ever want to move the whole term, you have to do the opposite to the sign to the left. So if this is a +4, what's the opposite of +4? So guess what? I subtract 4. What's 4 minus 4? 0, right? That's why we do that. It's because it technically cancels out. And this -4 gets thrown over there with the other buddy of his, the 11. So now you ask yourself, what is 11 minus 4? Guess what? You bring everything down, and all we have is x equals 11. That's what we're trying to do, is find what x equals. The goal is to leave x by itself always, our variable by itself always. Did that make sense? Spot how you could arrange to make every species happy. Once you spot that, do the opposite to the sign to the left, only to move the whole term. So this is what I mean. Or here's something that might be a little different. Tell me, in this specific problem, what needs to be moved, what number needs to be moved so that the worlds are happy, so that each side is happy? The 3, right? Because it's a 3, and it wants to be over there with the other number, because it hates the variable, right? But this one's a little different, okay? Because I said, hey, if you ever want to move something from one side of the equal sign to the other side, right? I said always do the opposite to the sign to the left, right? But that's only to move the whole term. To move the whole term. If you were to minus 3, you'd by default be moving the x with it, and you'd be moving this whole thing over there, creating a 0 equals 24 minus 3x. And that's not what we're trying to do here. The thing is, the whole opposite trick, doing the opposite to the sign to the left, is only used to move the whole term. In this specific case, we've determined the 3 needs to be moved, right? That's not the whole term. That's just a piece of the term. What you want to do is detach the 3 from the x, right? Do you know how to detach a number from a variable? You divide. So in this specific case, we divide by 3. That cancels it out. And then you throw it over there. And ask yourself, what's x? What's 24 divided by 3? 8. So now, in like a very, very rare occasion, why do we divide 3 here? Why is it that division is used to detach a variable from a number? Quite simple, really. Explain. Exactly. Do you remember what I just said previously? How do you move the 4? Well, you do the opposite of its sign. In this case, it was a positive 4, so you minus 4. Here is no different. All this means right here is 3 times x. What's the opposite of multiplication? Division. That's why we divide. But for some reason, people, they get confused and whatnot, and they're just like, oh man, what do I do here? Do I subtract? Do I multiply 3? Do I add 3? Do I divide 3? They get all these signs confused. And I tell them, hey, are the number and variables together? They're like, yeah. Then divide. It's the one thing that's used to detach the number from the variable and throw it over there. It's the detach operation. The whole opposite thing, the opposite to the sign of the left, the whole with adding or subtracting, it's used to move the whole term. Division is used to detach. Do we got that? Do we got that? Yes. Now there's one more. There is one more. No. But it's just another one. Because so far we now know when to add and subtract. It's when the number is by itself and you just want to move the whole thing. Right? If you wanted to move this whole term, all you did was minus. If it was a negative 4, you'd add 4, right? If the number and the variable are together, you use division to detach. There is one more that you might come across. X over 2 equals 17. What do you do in these situations? Well, here's the trick. Here's the trick. Always, and I say always, look to your denominator. All right? And what you do is you get that denominator, right? And what you do is just, well, not just, you kill it, you destroy it, and you throw it over there via multiplication. And that's all you do. X equals whatever 17 times 2 is. What's 17 times 2? So, whatever your denominator is, multiply it to the other side. So think of it like this. we times the bottom by 2. This is what really happens. You times the bottom one by 2 to make it cancel out, and then you multiply it over there. Ooh, 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 that one I won't explain why. Well, all this is division, right? What's the opposite of division? There you go. For some reason, opposites make things attract. Sometimes. So, recap. We're going to recap this right here, right now. Let's do an example of everything. Guide me step by step. This one's a little different. It has some negatives involved, right? But first things first, tell me, is each side of the equal sign simplified? Tell me, what needs to be moved? You're going too far. What needs to be moved? -5. Cool. You've determined what needed to be moved. Now ask yourself, how do you move that -5? Say it. You said it. Yeah. If you've determined this needs to be over there, because that's the variable, that's the term that wants to be with the other term, you always do the opposite, right? Or not always do the opposite. In this case, you just want to move the whole 5 over there, then just do the opposite trick, right? What's, oh yeah, sorry. It gets thrown over there because this one canceled out. X equals, what's -2 plus 5? There's your answer. You see that pattern? This is what you guys are going to be doing. Oh, and by the way, let's use this exact same example actually. Except let's add a negative to this. Tell me, what needs to be moved? Huh? -5, right? How do you move the 5? And then we had 3, right? This, my friends, is not the correct answer. You're not done. Your variable must always be positive. X equals something. Y equals something. Z equals something. Your variable must never be negative. How do you get rid of that negative? Ooh. Ooh, so close. Huh? Yes. Yeah. So good. If you want to think of it like that, there's technically a -1x, right? But are these attached or not? Is the -1 attached with the x? Yeah. So, how do you detach something from a variable to throw it to the other side? You divide. You divide by the -1. Cancels out and it gets thrown over there. X equals -3. You guys could have that in your head. It's fine. Think of a -1, divide by the -1, throw it over there. But you could just take even the easiest step of all. Literally, kill that negative sign. Just get it and chuck it to the other side of the equal sign. Yeah, you want to have that in your head. No, you learned it the mathematical way, which is correct. Because oh yeah, because you added 1. It's divide 1 by -1. But this is how I usually showed it. I was like, hey, get the negative and throw it over there. But then same thing, everyone always asks why? It's like, God, you really want to know? There's a negative 1, blah, 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 divide, right? But if this makes your life easier, in case there's a negative variable, get it, throw it over there, and flip the sign of the other side. If that was a positive 3, it became a negative 3, right? If it was a negative 3, same thing. Kill this negative sign. Throw it over there. All it does is flip this, right? Because it makes it a negative 3, which makes it a positive 3. So just get it, throw it on the sign, and whatever's on the opposite side, just flip its sign. Okay? That's in case you ever have a negative variable. Remember, you're not done if you have a negative variable. Check it. Check it, right? Oh, back to the fraction one. Keep in mind with the fractions. What if you have a 4 over x equals 2? So before I showed you this one, x over 2, right? And it was easy. You multiplied your denominator and threw it over there. This one, guess what? Same thing. Get your denominator, multiply it over there. As in, you do this. Multiply by x, cancels out, multiply by x. Right? The thing is, this one didn't just automatically give us our answer. We have to do one extra step. What do we do with this new problem? What's 4 divided by 2? 2 equals x. And yes, you could write it like that. For some reason, people think the x must always be over here. No, that's not the case. Either way, it's fine. Does all of this make sense? Does anybody have questions on this? One-step equations. Tomorrow, and from this point forward, we're going to have so much fun with equations. Why? Because everything that we've done is involved in equations. There's going to be more things on each side. There's going to be distributing. There's going to be combined like terms. There's going to be a whole bunch of movement everywhere. And if you mess up in one little part, your whole equation gets thrown down. I was going to say poop hole, but drain is fine. So that is that. Are we ready to do our practice sheet?
Yes.
Cool.